11.4, this would be considered part 2. We're going to talk about compositions, just so we make sure that we remember what these are. And compositions are f of g of x or g of f of x. We'll have to do both if we're trying to prove that two functions are inverses. And you will be having directions that say, are these two functions inverses? Prove using compositions. And you must do this math, or you don't get the credit. So I'm going to give you two separate functions. And I would write these down, and we are going to, you can pause the video to do that, and we are going to actually go over this. So I'm starting with f of g of x. The outside function is f, so I'm going to write this function down, but I'm not going to include x. So I'm going to do 3, where x is minus 5. Okay. Then after f, I see g, so what's going in the hole I left is the g function. So that's going to be x plus 5 over 3. And what I notice is that I've got x plus 5 divided by 3, and I've got that whole fraction multiplied by 3. Dividing and multiplying are inverse operations. So I know now I have x plus 5 left in the numerator and the minus 5 outside. And so my 5's will cancel, and I've just got x, which means they're probably inverses. I don't get to say yes because I have to go ahead and do the other version. So I'm going to do g of f of x, which means this time I'm starting with the g function. But I'm leaving where the x is a big hole. And after the g is f, so this guy is going to go inside. That being said, there is nothing to do with this parenthesis. There's no multiplication out front. There's no multiplication at the back. So really, we can pretend like they're not there. So I just have 3x minus 5 plus 5, which tells me minus 5 plus 5 can cancel out, which is going to leave me with a 3x in the numerator and a 3 in the denominator, and that's going to simplify to x. So I can say yes, they are inverses. I've just proven it by both answers equaling x. The second example, okay, we're going to do these two linear functions, which is actually not the point of what we're doing. We're going to do cubics in just a second, but here I'm going to start with f of g of x. Again, I'm starting with f, so I'm going to have 1/2 parenthesis minus 3. Everything but the x stays. I'm going to take the other function and plug it in, because g is second. And then I'm going to distribute 1/2 times 2 and 1/2 times negative 6. Half of 2 is 1x, and 1/2 of negative 6 is negative 3, and it is a negative, and I bring down this minus 3. These two are not opposite numbers. If I owe $3 to mom and $3 to dad, I now owe $6. This is not anything I can do math with. It doesn't equal x. I can't do anything, so I say no, and I'm done. So that's when they're not inverses. And now we're going to do f of x, equals x cubed plus 3. This is what we're working on now. G of x is cube root of x minus 3. Alright, those are your two functions. Again, pause it so you can write them down before this moves on. You're going to do f of g of x. So I'm starting with this guy. X does not appear, but everything else does. Notice the cube stayed. I'm going to put the other function inside, so it's going to be the cube root of x minus 3. Now, everything's being cubed, everything's under the cube root. So these two will cancel each other out. And that's going to give me x minus 3 inside plus 3 outside, which is going to show me that those disappear and I'm left with x, which means I must work this side. So I'm going to do g of f of x. Again, I'm going to start with the function that's on the outside, but I'm going to leave a big hole for the x minus 3. And I'm going to put in x cubed plus 3. Now in this problem you must be very careful. Everything is under the cube root. Only the x is being cubed, so I may not cancel this. What I can say is there's no reason for these parentheses. There's nothing outside of them. So I've got plus 3 minus 3, which will go ahead and cancel out for me. So that means I have the cube root, 3's are gone, of x cubed. Now, everything inside is cubed, everything outside is cube rooted, so I'm going to equal x. So I can say, yes, these are inverses. The last example that we're going to work, we're going to say f of x equals 1/2 x cubed minus 2. So we're working with this one so that you can see it. And g of x is going to be cube root of 2x plus 4. So we're working with this one so that you can see it. So I'm going to do f of g of x, 1/2, leave a big place for x, everything else stays. You're going to take this function and put it inside, so we got the cube root of 2x plus 4. Now, on this version we got parentheses cubed, so everything's cubed, and everything is under the cube root, so those two will go first. However, the 1/2 is sitting here and it's not going anywhere, and the parentheses cannot go anywhere because 1/2 is multiplying. So you're going to say 2x plus 4. So the cube and the cube root disappeared, nothing else. Nothing else. You're going to distribute the 1/2, and 1/2 of 2 is 1x, 1/2 of 4 is 2, bring down the minus 2. And you're going to say those are going to cancel out for me, and I got x. So now I have to work this side. Cube root 2 parentheses plus 4. Notice everything's under the cube root, so I'm going to put in 1/2 x cubed minus 2. Over here, the cube and the cube root canceled right away. Over here, that's not the case. Everything's under a cube root, but only the x is being cubed. And I can't cancel anything right now. The only thing that I can actually do is distribute right here. That 2's got to go to the parentheses, so I'm going to say cube root 2 times 1/2 is just going to be 1 x cubed. 2 times negative 2 is negative 4, and we got plus 4 coming down. And then I notice that these 4's will disappear for me, and so I'm left with the cube root of x cubed. So that's really just x. So I can say, yes, these are inverses. So this is how I prove inverses using compositions.